Hello. Good, hello. Good morning, sir. Am I audible, ma'am?
Yes, sir.
Mic check. Is it audible from my end, please?
Yes.
Okay.
Good morning, participants. On behalf of New Horizon College of Engineering and Department of EEE, I welcome you for the third phase of short-term training program on smart grid technology for energy efficiency and active demand side management, phase 3. And in phase 3, we are going to have the topic about an overview of smart grid infrastructure for demand side management. Now, I would like to call Mrs. Rashmi Madam to inaugurate the session.
Thank you, sir. Good morning, everyone. A warm welcome to all the participants and resource people for the short-term training program, Phase 3. The Department of EEE is very happy to organize this STTP program, Phase 3, on smart grid infrastructure and demand-side management. About the Department of Electrical and Electronics Engineering is one of the prestigious branch of engineering which was started in 2001 at NHCE. We are accredited with NAC A and NBA also. And we have Indo-French Center of Excellence in our New Horizon College of Engineering, MOU with the French Ministry of Education. Now, I would like to welcome all the participants, the resource people of this STTP on behalf of Chief Patron, Dr. Mohan Magnani, Chairman of NHE, I, Dr. Manjunatha, Principal of NHCE, Dr. Gopal Krishnan, Professor and Dean R&D, NHCE, Dr. M. Mahesh, HOD, Electrical and Electronics Engineering Department, and by all the organizers, faculty, and of NHCE. Now, I request our HOD, Dr. M. Mahesh, to address and give inaugural speech on this STTP. Sir, you are not audible, sir. Mic on. Thank you, sir.
A very good morning to all. It's our great pleasure to organize this 6 days STTP on smart grid technologies from Electrical and Electronics Engineering Department. I welcome all the delegates for showing their interest in participation of this 6 days STTP activity, as well as I also invite and congratulate our resource persons with their only one phone call attempt. They have agreed for this STTP workshop to serve as a resource persons. I also thank our coordinators for taking initiation and taking interest in organizing this 6 days STTP AICTE sponsored short-term training program on smart grid technologies. Thank you, one and all. I request all the delegates and participants to take a benefit of this 6 days workshop. Thank you once again.
Thank you, sir. Thank you. So now we will begin with the first session, and the first session today's resource person is Dr. M. Mahesh. Dr. M. Mahesh obtained Bachelor of Engineering degree from Gulbarga University with distinction in 1996. Obtained ME in Power Electronics Engineering, Bangalore University in the year 2000. Obtained PhD in Power Electronics field from NIT Rourkela, India in 2011 as a full-time candidate. Sir started his teaching profession in 1997 and worked in various institutes of Karnataka and also in foreign university like Ethiopia. Congratulations, sir. Sir is a technical reviewer of IEEE, IET, and also Sir served as a reviewer for various conferences organized in various colleges. Sir recognized as resource person in various seminars, workshop, STTP, organized in various colleges of Karnataka and so on. Sir's area of interest is soft switching technique in power converters, smart grid technology, renewable energy integration with grid and electric vehicles. Sir is guiding PhD candidates as a main supervisors under Vishweshwaraya Technological University from 2019 and presently guiding on adjustable speed drive elevators and also in field of digital control circuit power factor corrections and also in the field of reliable grid tied multi-level inverter for solar photovoltaic application. Now, I request Sir. Sir presently working as a professor and head of EEE department in New Horizon College of Engineering. Sir, it is very honored to have you here today as a resource person, and I welcome you all for the session. Over to you, sir. Welcome, sir.
Yeah. Mic checking. Is it audible? Mic checking, please.
Yes, sir. Yes, sir.
1 minute. 1 minute. Just give me 1 minute, please.
Okay, sir.
I'm connecting with that. Is it audible?
Yes, sir.
Okay. I remember during my childhood days, probably when I was studying second standard, there was a best practice wearing the uniform, wearing the shoes and socks and going to the school. That was the best practice. Most of the days in my school days, I used to wear one of my brother's socks for one of my legs. For my other leg, I used to choose a socks of my own because it was of same color and same size more or less. For one of my legs, I was using my brother's socks, and for other leg, my own socks. This was noticed by my mother and used to tell me, Mahesh, can't you recognize your own socks? Most of the times you are wearing your brother's socks for other leg. Why so? She was educating me. At the time, she was right. She was perfectly correct. But I was not doing this intentionally, wearing the one socks of my brothers for one leg, for other of my leg for same socks. So I was not doing this intentionally because I was in the learning stage. I was in the learning stage. My dear participants, delegates, please trust me, believe me. Till today, I am in the same learning stage because it is not with respect to wearing my other socks, but with respect to upgrading the technology. Very good morning to all. I have narrated this because every day the technology is changing. The upgradation is highly important and highly essential for today's youngsters, research scholars like you. Once again, very good morning to all. Mahesh speaking to you, and I welcome you for this technical seminar. I would like to share my presentation over here. Yeah, is it visible now? Is it?
Yes, sir, it is visible, sir. It is
Okay.
visible.
The term innovation, anybody can answer this? The term innovation distinguishes between a leader and a follower. A leader and a follower. For any technology, for any well-established companies or industries, if you take, there must be a definite goes in this way. And Going ahead, there is a one person who is standing like me, having an umbrella, he is protected highly from the rain, and the other person doing some different activity. Yes, please check. So this is, I can mention as a innovation is a state of mind. If I go ahead, so this is the way the people are working, the way in which if you work in a different direction, definitely you will be noticed and recognized by the society. You have to select your work in a smart way. You have to execute your work in a smart way. Going forward about this, as this STTP is focused on a smart grid technology, when do we say the system is smart? Really speaking, anybody can answer. Let us have a small interaction session now. When do we say a system is smart? I would like to address this smart in a general manner, in a generic manner, not with respect to a technology. Let us just 10 to 15 minutes, let us forget about the technology and let us speak in a general aspect. How does the smart work, the smart system work? Yes, we know a smart, SMA or T. If I just deal with the very first letter, that is a specific. What do you mean by this? In what way the term specific signifies or gives a significance with respect to the smart system? The word specific indicates the specific goals or a specific objectives which are there in front of us. A specific objectives ought to be determined in order to obtain a smart system. The second one is the measurable. A team of people will be working on a specific goals or a specific objectives. Whatever the objectives we are going to achieve now, that should be in the measurable form. There should be a proper outcome. It should be easily understandable by every society person. So this is the contribution from our team should be a measurable in the form. The next one is the achievable. A stands for achievable. Whatever the targets or the goals we kept now, they should be in the achievable in nature. If we imagine or if we fix up some directions or some goals which are not achievable in nature, no, that cannot be possible. If I dream something like this, within 1 hour, sorry, within 1 year, I am going to achieve a 1 crore of rupees in my pocket. 1 crore of rupees in 1 year. It is my dream. Is it possible? You please check. You should have a proper plans with respect to that. Please, whatever the goals we are going to fix up, they should be achievable in nature. Next one is the realistic. Whatever the outcome we are going to desire, whatever the outcome we are going to get, that should be realistic in nature. Means that should be useful or it should be utilized by our common man people who are in the society. So whatever the product we are going to develop, that should be utilized by the system or a society so that everybody should have use of it. Last one is to achieve all these things, measurable, specific, achievable, and realistic, we should have a proper time management. If we don't have a proper time management, we are not at all achieving anything or not at all fulfilling any nation or a society requirement. So these are the 5 important parameters. So specific, measurable, achievable, realistic, and timely. These are the important parameters one should adopt in a progressing of your research so that we are able to get a smart system. So your smart system should fulfill all these 5 parameters. Okay. We say very term in this smart way, smart system. Just I spent only a few seconds on this. A smart grid. Generally, after the smart, we get a grid. What is grid? A grid is a latitude or longitude lines which are on the globe. We are going to find these helps. These latitudes and longitudes will help to identify a particular location on the Earth. All of us know. And also, some people who are not technical, who are not geographically expertise, so they go for some drawing of the images. They have on an image, they go for some standard grid lines and they take a white sheet, and in the white sheet also they have a grid lines and they start drawing it. They are going to get a good image of this. And also you can refer this grid line in a different way, that is a particular pattern, a standard pattern which signifies something. With respect to this electrical energy, I speak this smart grid as a network of electrical wires, and equipments that supplies electricity to a large area is the best or a best definition of your grid. In general grid, a network of electrical wires and equipment that supplies electricity to a large area. With respect to our electricity, this is the grid definition. Okay, let us come on to this smart grid system. If you have to understand, if I say the word smart grid, you should imagine that a digital technology. Because of the digital technology, the smart grid will progress. That is the basic point. Here in digital technology, we are going to achieve a two-way communication. So I will discuss one by one what is this two-way communication and in what way it is going to help each customer as well as the service provider or utility provider and so on. So in order to have the electrical energy consumption, first we should have a utility, that is the electricity power generation, and followed by we have loads, various loads. We have an automobile loads, maybe a lighting load, industrial load, motors, and many more. Okay, commercial loads and many more. These are to be connected by a systematic plan, that is a two-way communication. I am giving the broad idea of your smart grid technology. Okay, when I provide a two-way communication between these two elements, one is utility and the other one is the various loads through a transmission and distribution system. This is a smart grid system in broad sense. The sensing along the transmission lines. I am going to sense the various data from the loads as well as from the utility, and exchanging of this information in two-way communication will give the smart grid definition. In broad sense, I can say like the internet. Please remember this statement. Like the internet, the smart grid will consist of controls, computers, automation, and new technologies and equipment working together. We have a control units, computers and automation, and the new technologies. Whatever the new technologies, it may be a Zigbee technology for communication or Bluetooth technology. It depends on again the application and the purpose where they are going. They are very relevant to adopt and install. Yes, but in smart grid technology, these technologies will work with electrical grid to respond digitally to our quickly changing electric demand. See, in our smart grid technology, all these computers, control units, automation, and new technologies and equipments will work together for the electricity flow in bi-direction as well as with a data communication. Now, in the broad sense, I can put the definition of smart grid in this way. A smart grid is an electricity network enabling a two-way flow of electricity and data with digital communications technology, which enable to detect, react, and proact to changes in usage and multiple issues. So we are going to detect some parameters or some changes or the state of some particular situation in the grid technology, okay, in the grid system. We are going to detect and we are going to react them. React means whether it is an abnormal situation or a normal situation. If it is an abnormal situation, we have to react to that. How we are going to react? We have to react proactively, very quick response. Quick response we are going to adopt for the possible changes, and many multiple issues will also be considered. Yes, the smart grid have self-healing capabilities and enable electricity customers to become active participants. So whatever the abnormal situation come across, maybe technical faults or any things which are not desired in the regular system, so that will be self-healing capabilities. We are going to adopt a new technologies and advanced technologies and control systems so that any faults can be healed up of their own. We say it is a self-healing capabilities and which enhances the electricity customers to adopt or to become active participants. Okay, let us deal with this overview and advancement of peak load saving methods using the smart grid technologies. Yeah, this is very important. In the broad sense, I would like to give, there are 3 plus 3, 7 various components. Among 7, there are the 3 important components I would like to highlight. One is the market. This is the market, and next one is the operations and the service providers. Please observe here carefully. There are 2 different lines we have used here. One is a continuous dotted line we say, and it is a line, one more line, a dotted line, and a communication flow is there, and electrical flow is there. Please observe here, apart from these three main group, we have four different elements. One is the bulk generation unit, that is a generation plant, and the transmission and distribution elements, and followed by last one is a customer. Here the customer will going to receive a power and they are going to consume it, and these two fellows will help in transferring the power and distributing the power, and this is the power generation. All these four units are connected through the electricity flow. Please observe this dotted lines, what I am showing here. This is the electricity flow is happening. It is okay, and now these other communication lines are connected, each market element. This market element is connected with all other points. Please check, the market element is connected with operations, service provider, as well as customer, distribution, transmission, and bulk generation. Each and every component is communicated with all other components directly. Please check this. For example, this operations. Operations are connected with all the four different elements, as well as remaining two, service provider, as well as the market. So in every point, one point to other point, in each and every point, arbitrarily you choose any point, and from that point to all other points, they are communicating digitally, in the sense that is a two-way communication is happening. This is the basic model of a smart grid technology. And there is a power flow between the power generation plant, transmission, distribution, and customer. It is, of course, a dual power plant also. Dual power flow can also be there. But please observe this. This is a data communication is happening between each and every point in any point in the grid to any other point in the same grid. So this is a data communication, and a power flow is happening in various components. The same expression I have given you earlier, the smart grid technology is one of the efficient ways to implement the peak saving method. The smart grid technology can make the conventional electrical grid into modern grid with two-way communication as well as a two-way power flow. So we will discuss these operations, what is the role of operations and service providers and this market one by one in the next coming slides. The smart grid technology can be implemented in several parts of the power systems across the globe in the nation. You take any nation based on the resources available. If I am having a very good hydel resource, the water resources is very high, it is available. Yes, I can go for a hydel power plant for that particular remote area, and I can serve a power for that with a smart grid installation. And if I have a renewable energy, if the very hot city, most of the days in a year, if I get a large sun rays, so that I can collect that the resource, and I can convert it into electricity, and I can use for that particular remote areas to a microgrids and so on. So these are the advantages we can take from the smart grid. Both the consumer and the utility are economically benefited by converting the existing electric grid into a smart grid. The existing electric grid is also referred as a conventional grid or a traditional grid, and any existing grid can be converted into a smart grid because the smart grid has its own merits. So in the initial investment may be quite high, but of course the learning, maintenance, and the running operation expenditure will be less. Now, let us have a small discussion between the difference between the traditional grid and the smart grid. In the traditional grid, the operation control of the existing system will be of manual kind, and it works based on the electromechanical techniques. We are going to use all traditional equipments like your electromagnetic relays and the magnetic switches and other mechanical switches will be incorporated. Whereas in the case of smart grid technology, the on-off control system for disconnection and connection of the supply of the grid is fully automated, and it works based on the digital control system. So as we have adopted the advanced techniques, using it may be an advanced relays will be incorporated, they operate from the digital signals. So based on that control action and the control action as well as the automatic techniques, they are going to operate. And communication is only one way. See, from the electricity board, you may get a call. So and so person or so and so customer has not so far paid the fees. There is no again reverse communication from customer end to electricity board. That is not happening much. only by phone call, and they are taking your query, and after 1 week or 1 month they are going to troubleshoot your problem. But in case of smart grid, communication is happening continuously between the utility and the consumer. It is continuous. Okay, so that is the advantages of this smart grid. Next, the generation will be in one place. Here, in case of traditional grid, the generation will be of one place, that is called centralized system. And hence, the existing power system, the distance between the power plant and the consumer premise is very long. And so, the use a transmission loss is going to happen. We are going to have a more power loss in the traditional grid system. The same thing, if I have a decentralized system, in the case that is also referred as a distributed generation capability or distributed system, so transmission loss can be eliminated so that the efficiency of entire system will increase. In case of traditional grid, the sensors for monitoring the health of the power system in the existing system are very limited. The very limited and conventional sensors are used in this. In case of the smart grid, due to the smart communication and digital control system, a maximum number of advanced sensors will be installed so that they work efficiently, and also that they will inform about the fault status of the power system immediately, so that immediately that can be troubleshooted. Now, in case of traditional grid, the monitoring of the fault and all the status of the power system is manual, and it needs more human resources, and more manpower is required, and also it takes longer time to rectify the faults. Whereas in case of smart grid technology, as I told earlier, it is a self-healing capability is adopted. That self-healing capability feature is adopted in the smart grid technology, so that the monitoring is too easy, and it has data logging capability. Data logging, I am going to explain about this. Data logging can be used to review the status for future analysis also. So data logging, you please write down this definition. It is very, very important for the people who are working on smart grid technology. It is an electronic device to store the data over a period of time, over a period of maybe 1 year data or 6 months data or 1 hour data, whatever we are going to plan. It may include a data acquisition device such as a plug-in boards or a serial communication system. So it is just any data storage equipment. Some people may use a computer as a real-time data recording system. Okay, so data logging is nothing but equipments we use for the data storage over a period of time. Now, the power system will get affected largely in case of traditional grid. The power system will get affected largely when the disturbance occurs in the existing power system. Yeah, it is also true, and also the fault may be cumulative in nature. If one area of the fault is affected, and that may be cumulated to the other area, and the same thing will spread to the other neighboring junctions or neighboring nodes. Whereas the fault occurred place is islanded automatically and immediately in the smart grid technology. If it is, that's what the advanced sensors are used, the advanced equipment will be used. No? So if it is identified any corrupted area, the fault area, that will be isolated immediately, and so the fault will not affect the entire network. And the recovery time in the smart grid is very fast due to identifying the fault location in very short duration, whereas in the existing system it will take more duration to identify the fault location. So this is applicable to the perfect difference between the traditional grid and the smart grid. In the smart grid, the fault will be immediately identified, whereas it takes more time in case of traditional grid. Yeah, when I speak about the very important parameters or various components of this smart grid technology, is that there are 4 important components in smart grid we are going to study. One is the smart infrastructure, and the smart communication, the smart management, and smart production. These all are incorporated in a single smart grid system. All the 4 components are very, very important. And again, the smart infrastructure has 2 components. One is the energy system, other one is the information system. This information system is nothing but an data storage. The information is stored. That is, a digital techniques are employed over here. The energy system mainly deals with the energy flow. It is from sending end to receiving end, or with transmission and distribution, and also the consumer and various nodes. These are the various components of a smart grid. There are 4 first primary components: are smart protection, smart infrastructure, smart communication, and smart management. We will discuss one by one. And the smart infrastructure again has two components. One is the information system, that is the digital system, where the importance is given to the data storage. Okay, and this is the energy, electrical power energy flow to the from generation station to the customer through transmission and distribution. Yeah, when I discuss about this smart energy system, there are three components again: the power generation, power transmission, and power distribution. So the smart grid technologies are automated and enable two-way communication, giving the power generators to ability to monitor several plants and implement control strategies in fraction of a second. The control actions and identification of faults and implementation of control strategies will happen in a fraction of second. Okay. And here purposely we have not shown the consumption because the consumption area is not a part of a smart grid. Right? The smart energy system has three components: generation, transmission, and distribution. Now, the transmission and distribution intelligence part of the smart grid that applies to the utility distribution system. Here, the transmission distribution intelligence, whatever we have here, will a part of a smart grid that applies to the utility distribution system. That is, the wires, switches, and transformers that connect the utility substation to the consumers. Okay. In this way, this is happening now. This is a very important. It is just imagine a smart grid. Whatever the smart grid is, maybe having a various loads. This is the industrial load. This is a commercial or a building load, and this is the home load. Right. So see here, the single image explains 1,000 words. A single image is equivalent to the 1,000 words. In that way, you just imagine there are three different kinds of communication over here. The solid line indicates the internal communication. I have three various loads: industrial load, building or commercial load, and home load, that is a residential load. I just discussed about this electric vehicle a little later. And all these are directly connected. There is an internal communication between each and every load. See, industrial load, building load, and home load. We have a direct solid line. It is represented by a solid line. We have a direct connection in case of electric vehicle also. Right, in the electric vehicle also, again you take one more point I would like to add for that little later. Okay, I have a strong connection or communication between all these areas. In these areas, they have the self-power generation capability. For if I take an industry has a self-power generation capability through a wind generation. They have their own setup. In the same way, the building load will be served by a thermal plant. It is having its own power generation capacity, and also this home is having a solar generation power plant. They are taking care of their own power generation. In addition to the own power generation, they have a meter technology, automation, and the lighting. Lighting is again an electrical load. Okay, and in the same way, they have a meter technology, means data measurement, that is power flow measurement infrastructure, and its own campus, and the building automation is also incorporated. Here again, the home also is having the various meters, automation, and appliances. This is what. So this electric vehicle block is shown because nowadays, after 10 or 6 to 12 years, there may be a huge electric vehicles, and these petrol bulbs in India may be replaced by the charging stations, electric vehicle charging stations. That's why that is also referred as one of the resources in the coming years. That's why it is added. In the same way, all the three loads in the same way, electric charging stations can be considered as one more point in the power. Now, the third line indicates the electricity flow. The dotted lines is an electricity flow. We have given a flexibility for the power flow, that is a two-way power flow between the building to industry or industry to building. In the same way, from building to the residence or residence to the industry, vice versa. If this is having an extra power, if this residential area it does not have generation of high power through the solar, so this person, the industrial person, generated high power, extra power can be delivered to the home. In the same way, vice versa, from building to home or from building to industry. That is happening here. And now all these loads, various loads, are well connected with the two-way communication in all these four points. That is, one is the service provider, operations, distribution, and market. All these four important teams will have a direct connection with all these various nodes. And also, please remember, it is a two-way communication is happening. I will discuss about the service provider and operations and their roles and regulation, roles and responsibilities little later. The same thing is highlighted over here. The communication for the consumer domain includes advanced metering infrastructure with or without internet. So this is advanced metering infrastructure with communication for the consumer domain. Yes. So this, I have a customer domain over here. The service provider will well connected with all these nodes. The home appliances can be interconnected with sensors and relays to monitor the control. In smart grid technology, all of each and every appliances, either in the industry or home or in the building, commercial buildings, all equipments will be connected through the relays or without relays to monitor and control the status of each and every appliance. All the information from the home can be transmitted to the utility such that the consumption data, time of use, and appliances individual peak load. The entire data, the average power consumption, peak power consumption, and the actual hour of consumption of various loads will be shared to these service providers as well as to the operations from each and every node. The consumer can get the cost of electricity from the utility to with respect to different time costs. So these service providers and also this operation team can provide a data about the tariff or the price or the time of use of electricity to the particular appliances can be shared. We are going to share, this operation team is going to share the various data to the consumers. See, one more point I would like to highlight here. Nowadays, we all are well connected with the YouTube and various entertainment media and all, but we are not well connected with the electricity board of your own state. They are not frequently sending or keep on sending the messages like this month, this much is the power you have consumed and only the 20% of the power is left in your quota. Something like that they are not sending. But we used to get a similar advertisement, SMS and text from the commercial team. Commercial team means maybe from the bank applies that this much loan is we are going to provide, or this much from the supermarket, from the big bazaars and other leading market people. Now we are going to get this Saturday, Sunday, this much is the discount we are going to provide, this much discount and less amount. They are going to advertise now. In this way, we are well connected with the commercial part, but we are not well connected with the electricity board with respect to our power consumption and the usage and our leakage of our power loss and so on. So in the next year, if the smart grid is incorporated in every point in our nation, we are going to get a sequence of messages about our power consumption, and they are going to educate us. They are going to create an awareness about the power consumption in the years to come if we have the smart grid technology systems. Now, go ahead with this. I was speaking about AMI, Advanced Metering Infrastructure. The Advanced Metering Infrastructure is an integrated system of smart meters, communication networks, and data management systems that enables two-way communication between the utilities and customers. So it is a set of various meters and communication networks and data management systems, so which enables us, which supports us in having a two-way communication between the utilities. Utilities in a sense, service providers, that is the electricity utility grid, the main electricity board, with each and every customer. Customer may be anybody. It may be from a commercial customer, it may be industrial customer and residential customer and so on. Yes, if I speak about the market domain has various 6 team members. The first one I discuss about the ancillary operations. Ancillary operation in the sense that is beyond the generation and transmission of power. So generation of the power and the transmission of power, that is the existing technique. And apart from that, if I want to provide a stabilized voltage, there may be a voltage variations in a large margin. So stabilized voltage, or to provide a standard frequency. The frequency is going to vary, so to some extent. So in order to, or if you are providing a spinning reserve is nothing but a capacity of a plant connected to grid, ready to take a certain load. For example, beyond these normal operations, beyond the generation and transmission, if we work on the voltage support activity and frequency support activity and spinning reserve, we say it is an ancillary operations. In order to elaborate this spinning reserve, if you imagine that the 10 generators are working to provide a sufficient power to some industry, let us imagine like this. Okay, if any one of the generator among them, among 10 generators, if any one of the generator is stripped out, if it is stripped out, the time taken by the remaining 9 generators to compensate with the additional energy required by that triple one generator. Okay, so time taken or the capacity of that remaining 9 generators to get connected with the entire industry to take that additional load is a spinning reserve. We may, technically speaking, we may come across a positive spinning reserve as well as a negative spinning reserve. If you are really interested, that is one good new area of research where you can focus. People, please note down this: a spinning reserve. This especially this comes in ancillary operations. One can have a good work on that. And in a similar way, I have a market management system which includes the market managers, include the independent, would like to say, operational services, independent service operations. ISO stands for independent service operations for whole market. That market, in the sense, it is an energy market. Please remember, my dear delegates, it is an energy market, right? Power and energy market. And retailing, selling the power to the end customers. The customers may be anything, right? You may have an industrial customer, you may have a commercial customer, and the automobile customers, or things like that. Okay, so and the distributed energy resource aggregation and the trading participants in market and buy and sell energy. That this is not still well established in Indian scenario, that is the trading of electricity. So still it takes some more time. If we exhaustively work on the smart grid technology, if the smart grid technologies are well established in our Indian nation, so it is going to come up. And the market operations, the make a particular market function smoothly. See, in a sense, the market, if I say that there are various sectors, right? In the railway engineering, that they use electricity, and in the commercially they are using electricity, and in the irrigation, that is agriculture, also they use electricity. In all the sectors, biomedical engineering also, in medicine also, we use electricity. In all industry, all variety of industry, transportation industry, medical industry, drugs industry, things like that, right? Everywhere. That is, again, I can say that entire thing is a market. Each and every market, medical market, the transportation market, and the agriculture market may have its own different parameters to match or to have to synchronize with the government guidelines. Okay, that is, to make a particular market function smoothly, we should have a standard guidelines. So this, your smart grid is going to enlighten much on the standard guidelines governed by the nations. Okay? Here, the same expression I have given over here. Okay, I was speaking this. The consumer will have the details about the unit cost of electricity with a different time of slot. Now there is a trend in abroad, everywhere in abroad areas, right? So there is, based on the time, they are going to have a tariff. Morning session, this is the power. If you consume 2 units of power or 3 units of power, so for this much unit, this is the price. In the afternoon session, the tariff may be the different, but in the peak hour between in the evening 6 p.m. to 9 p.m., the tariff may be different. If I incorporate this smart grid technology in the nation, these are going to update in our present day's life. Now, the consumer has an option to reduce the usage of electricity during high cost time slot. During the peak hours, for example, if I take a peak hour, generally 12 o'clock afternoon every day, most of the industries will be drawing the more power. When that is the case, no, the residential people may not get a high power. Okay, so in order to match that peak demand by the industry, for the particular hour, maybe 12 o'clock, which is not at all a lunch hour, and all the machines in the particular industry will be operating, so that there will be a high demand in the electricity, so that the residential, the service providers may cut down the power for short duration, so consumer have an option to reduce the usage of electricity during the high cost time uh, things like that will go on. Okay, and if it is a too high, right, so we are not going to use the electricity, right? So things will come into that picture. Okay, now avoiding the use of electricity during the peak hours, the utility need to not to spend more money for the generation of the electricity. All these are the market oriented and the price oriented points we have listed. We please go through that and try to understand the same. All this type of framing of the cost of electricity was decided by the market domain. It is in the higher level, in the nation level, that is. Of course, if it is applicable to the state, means the particular state committee or state body who are working on power and energy will take care of that. And managing the big data with security and the timely communication between utility and the consumer are some of the implementation challenges for the smart grid market domain. You please little elaborate work on this. The safety is very, very important. When, as I told, that there is a digital data is huge digital data is going to create in the smart grid technology. Managing the big data with security is very, very important. That is the one area. Cyber security also we can refer in another way. Cyber security is the one area where the electrical engineers can focus on that much. But in India, it is that much not well established. We are in the STTP, we are giving this idea. Please focus on the big data and its security, especially in the smart grid technology. And also, you should be good at communication also. So this is one area where we can focus on this. Okay, so managing the big data with security and the timely communication between the utility and the consumers are some of the implementation challenges for the smart grid market domain. So these are the market domain various parameters. And coming to the service providers, we have a various. It is again, this is having 7 groups: customer management, installation management, and building management, and home management, billing, account management, and emerging services. The service providers should be always upgrade their technologies. Whatever the technologies, new technologies and new techniques are going to come in the industry, from the industry end, or maybe with respect to the computers, or with respect to the control units of our power and energy, right? They have to upgrade, and the same thing ought to be adopted in the existing grid system. That should happen. That will be taken care by the emerging services. And the customer management. The customer management will take care of various customers. The customers may be from the railway transportation, the customers from the agriculture, customers from the industry. This customer management will be knowing about the requirements and the demands from the various customers, and they have to study, and accordingly they have to develop a tariff based on the season wise or based on the time of a day and so on. And installation and management, see, once it is upgraded, the installation is also again a challenging task. Nowadays, the advanced sensors and advanced relays, technical digital relays and other things should be well skilled in the installation of the new equipments, especially in the smart grid technology. In this way, it goes. All these various team will be having its various roles and responsibilities. And with respect to the building, it is a digital building is happening. Nowadays, it has become very easy, right? Whenever you go, in any supermarket, the billing system is very easy. The manpower has also come down, and for every product there will be some code bar, and looking at the bar, so there is a small lighting instrument, and they will write the price, and easily they will do the work, right? So the building, in the building also automation here has come up. The same thing is applicable here. The consumer can contact the service provider in case of any emergency. So it is a two-way network. It has become very easy to communicate now. The electricity installation for the new consumer and the electricity maintenance for the existing consumer are taken care by the service provider. So for any grid node, there will be a new consumer will be there and a old consumer will be there. For all the consumers, the electricity service provider will be taken care. And electricity for buildings is maintained by monitoring and controlling of usage. Electricity for buildings is maintained by monitoring and controlling of usage. So building monitoring and controlling monitoring and control will be taken care by the smart grid team members. Okay, when I go ahead of this, so this is the various operations we generally come across in the smart grid technology. See, all and everything is important over here. We have all other operations. See here, we have a monitoring, supervising is there, and so this is a digital supervising and automation. Through the automation, we are going to monitoring. The manpower is up to some extent we are going to reduce from this smart grid technology, and we have a control actions, the advanced techniques, the advanced control units are to be incorporated, and fault management. Fault management includes the identification of the fault and the remedy we have taken, and the how speed, in what speed we are going to rectify the fault. All are included. If I say a fault management, first identification of the fault and type of fault, what type of, whether it is a lower level or medium moderate level or higher level, what is its scarcity, what is its critical state, identifying the state of the fault and for its remedy. It is a self-healer or it is not a self-healer. If it is not a self-healer, immediately it is to be disconnected and some other team member will come and operate that, and things like that. It is continued. And analysis indicates the power and energy consumption analysis and transmission and distribution analysis. And if I speak about the data storage analysis, and in all the direction it spreads out this unit. In the same way, reporting and statistics. Reporting is a technical documentation and the study of the statistics. So what happened in the winter season and what is going to predict or what is estimated in the next coming summer season, things like that. The technical reporting as well as the statistics analysis. Calculation. So with these two will work together. Calculation and reporting and the statistics will work together. And the training. See, as I told in the beginning of my seminar, very 15 days once or 1 month once, the technologies are changing. Whether it may be with respect to the communication, with respect to the advances in the sensors or PCB design of boards for which are going to install in your smart grid, so and so. For this upgraded area, the team has to be trained continuously in order to have a continuous smart grid operation in the smart grid technology. Things like that. And now, the records and assets. The records, in the sense, the data, recording the data and maintenance of the data, and as well as the assets. Assets means the various assets will be there in your smart grid system. So if I speak about much on that, no, it will take 1 day for about the records and assets of this smart grid technology. And you can, if you are really interested in particular that, you can have a good books are available on that, or you can Google it. And the other one is the operation planning. Operation planning in the sense, see, the energy demand by the industry will be of different requirement or different demands, and the energy demand by the commercial buildings or from residential areas or from agriculture for automobile, it will be different. So these service providers should work together and they should have a proper planning with respect to distribution of the energy, and so that will be operation will be done in a smooth way. And this also well connected with your maintenance and construction. The operation planning is also well connected with maintenance and construction. And this is the extension planning. See, once if I incorporate or once if I start the smart grid technology this month, keeping in the mind of next 5 years or 10 months, there are going to become a new layouts, maybe in the same area. I am going to get a new layout. It is expected, right? Maybe after 5 years or 6 years. Yeah. So as for that, again, additional residential energy is required. Keeping that in the mind, we should develop a grid in such a manner that it can be expandable for the next few years, right? That is the extension planning. Keeping those things in the mind, we should plan our design and development of a smart grid technology. And all these are interconnected in this way. And these are the several points you can look into this. Now, when I speak about, let us deal with the exact title of your work today, that is the peak demand. When do we say a peak demand? That is especially in electricity, when do we say a peak? The peak demand is also referred as a critical demand or a maximum demand. The peak demand usually caused by the spikes of increased usage of electricity by households, industries, and commercial consumers. Generally, this will be peak. Spikes will come because of the sudden changes in the industrial power demand as well as the commercial consumers. Of course, from the households will be there, but up to some extent it is manageable. The demand for Electricity varies depending on the usage. Depending on the usage, the demand of the electricity may vary. Again, that depends on the sector, where the household sector or industrial sector or commercial sectors. And so now, whatever the slides I'm sharing now, next 3 to 4 slides are very, very important. Please be attentive for this, because we are going to identify some of the research areas where you can start your doing research on. Peak demand is never constant as many consumers get connected to power. See here, it is not constant because it is variable, generally variable in nature. Today, after 12 o'clock afternoon, if I have a peak demand of some 2 megawatt, 2 megawatt of power is my today peak demand. Tomorrow, it may not be very safe. It is not again 2 megawatt. It may have a 2.3 megawatt. Again, 300 watts of power is highly required because we are running in that way. We are working in that way. Maybe it may be from the commercial areas or it may be from industrial areas. So this is a peak demand. And now, why minimization of peak demand is required? So this is a very, very important. Please observe one by one. So one or other points may be matching with the same meaning. Please focus next 2 to 3 slides. When the demand goes high, that is the power demand goes high, peaking plants are operated to meet the difference between the base load and the peak load. Generally speaking, for all the loads, which may be industrial load or commercial load or house residential load, we have a common baseline, the actual average level of power consumption, that is a base load. During certain hours of in a day, there will be a peak load. When peak, definitely it will be, that all of you know that the peak load will be higher than the base load. There is a small difference. Now, when the demand goes high, the peaking plants are operated to meet the difference between the base load and peak load. Peaking power plants are more expensive to operate. Why? In general, I can say, see, peaking power means it is an extra power. It is an extra demandable power. In order to get that additional power, that extra power, I should use a more number of diesel generators if the power generation is through diesel generator. Or if it is not from the diesel generator, if it is from the renewable energy, I should have more number of PV modules installation, and I should store the energy in the battery again. So for this, an additional investment is required. So that is the operation of additional diesel generators as well as the additional PV models with battery management. That's why, so this is more expensive to operate. That's what I've done. The peaking power plant are more expensive to operate. These additional diesel generators and additional power models are required with battery system. That's why it is more, because for that also investment is required. During the peak demand time, generation cost is high. Yes, this is one of the same. The generation cost is high because I should use the additional diesel generators as well as I should use the additional PV models. That depends on the location and again your requirement where you are using those things, right? So hence it is cost is high. Per unit cost of electricity is high during the peak hours. As this is happening, we are investing more money in order to meet the high demand. Yes, the per unit cost is going to increase for the customers. The consumer need to spend more money for electricity during the peak hours. So this is the same, because more extra expensive we are getting, we are putting on the consumers. Yes, consumer has to bear with the extra price. So reduction in peak demand will reduce the generation cost as well as the consumption cost. Now, if we adopt some good techniques to reduce the peak demand, we reduce some peak demand so that the generation cost as well as the consumption cost will come down. That is our main objective. This is again one of the good areas of research one can focus on this. Okay, how to reduce a peak demand? In order to do this, we have this information: the implementation of demand side management. In order to incorporate this demand side management, see how this is the one of the method. Demand side management is a good management system to reduce the peak demand. So we have a demand response. We should have a demand response as well as the energy efficiency. If we focus on this in the demand side management, we are able to reduce the peak demand. So now I am going to tell how to reduce the peak demand with a technique of implementation of demand side management. The demand side management has two components. One is the demand response, we should know, and another one is the energy efficiency. Now, demand response, I say, So what do you mean by demand response? Most of you may not be knowing, and some of you will be very familiar with this topic. You please understand once again. Here, demand response is a term used for programs designed to encourage end users to make short-term reductions in energy demand in response to a price signal from electricity. I repeat, it is used for programs designed to encourage end users. End users, we are the end users, the customers, the household customers, to make a short-term reductions in energy demand in response to the price signal from the electricity. Based on the price signal, I am going to reduce my energy consumption. Means we are going to reduce the unnecessary power consumption. That is a demand response. See, just observe here. There are two columns here. First, I will just speak of this incentive-based demand response programs, direct load control. First, I discuss about this each and every. These are very important points. Please note down. In incentive-based demand response programs, I have the very first technique. One is the direct load control. The direct load control deals with, according to the advanced agreement between the customers and utilities, utilities can remotely control some customers' appliances such as air conditioners and water heaters. See, there is a strong agreement between the utility, that is the power grid governing body, as well as the control customers like us. Remotely, they can control some major appliances like air conditioning machines and water heaters. Water heaters are used exhaustively in the industries, right? So those are the things. To participate in this method, customers need to be equipped with a remote control switch system so that utilities can reschedule turn on or turn off of the appliances. With providing information to the customers, it may be industrial customer or commercial customers, the governing body, that is the utility team, can directly control the load. It is their turn off or turn off. It is an agreement between the utility and the consumer. With their permission, they are going to disconnect the power. Second one is the interruptible service. In case of interruptible service, compared to the direct load control, this method is normally applied to the industrial sector and large-scale commercial sector. When the system is congested, means when there is a high power demand, customers are asked to reduce some loads to certain level. So the customers will be requested to reduce some loads up to some extent. By participating in this, customers can receive a rate discount or bill discount. If the customers are supporting with the utilities, they're telling during these hours we are going to interrupt your power supply. Yes, if the customers are agreed for that, they are going to get a tariff of this at discounted rate. At a lower price, they can use the power, because for certain duration they have given a power to the other industry which are working on with demand, high demand, right? However, in case of same interruptible service, if the customers fail to respond to the predefined time period, they could receive penalty. So this is also incorporated. This is the standard guidelines. It is an understanding between the service provider, that is utility grid, and the customers. Okay, so this is about the interruptible service. The last but one is the demand bidding. Please go through this. It is very easy to understand. Instead of being asked by the utilities to take part in demand response programs, customers can make decisions by themselves in this method. The customers can make a decisions. On this basis of generation and demand situation, utilities announce the total amount of electricity that must be curtailed. Curtailed in the sense to reduce up to some extent. They are going to reduce up to some extent the power demand from the customers. The customers can bid for the amount on the basis of their own situation and the wholesale market. The customers can bid, the customers can demand, okay, this much I am ready to pay only for this much amount of rupees for this much of power. So this is a kind of again a bidding between the utility and a customer. Based on their demand, they are going to fix the price for the. In this way, we are going to reduce some demand response. Now, the last one is the emergency demand response. In case of emergency demand response, I would like to share with this good example. If you consider two industries, let us take the one industry does not need a high power demand. There is no demand is required for one industry, but the other industry, which is a neighboring industry, is in need of very high demand for 2 hours between 12 o'clock noon to 2 o'clock noon. These hours. Now, the first industry, which does not need any additional power, it does not have any high power demand. That power can be shared with the other industry, which is in the high demand of power between 12 o'clock to 2 o'clock. It is a just mutual understanding between certain customers. Between, if you take some 2 to 3 industries can give a power to other 2 to 3 industries because they are in need of very high power, because the power is of high demand for that particular industries. In this way, emergency demand response can be shared. It is a sharing of my power with the other, because I am in not need of high power or demand. I am not in a demand of power. I can share my power with the other industry. In that way it will go. And the last one is capacity market program. In case of capacity market program, please listen. When the system is short of reserve, customers are required to reduce their predefined consumption. When the system is short of reserve, when there is no high power is available sufficiently, the customers are required to reduce their predefined consumption. They will be having a predefined consumption level will be there. They have to come down with respect to that predefined consumption level, and this announcement is normally released by 1 day ahead. Before 1 day only, the utility team people will announce to the customers. So all these are the parameters which are come under the smart grid technology. But nowadays in India, in most of the states, we have not adopted these, but these are going to come in shortly. And left side, I was discussing about this. The price-based demand response programs is a time of use pricing. In a day, there will be different slots. Morning session, this is the time of pricing, and the afternoon session they will charge, the electricity board will charge for different price, and the afternoon session and the evening session is a peak hour in the residential area. The time of charge will be different based on the time they are going to charge, or also it may be applicable to the season wise also. During the winter season, this is the power tariff, and during the rainy season, this is the power tariff, something like that. They may have the standard guidelines. And the critical peak pricing in the sense that critical peak in the sense very short interval, the very high demand by some particular industry. If that is happening, all consumers from the commercial end and the residential end will be stopped, and this added power will be the power from the residents and the power from the commercial will be given to that industry. That is happening in a critical peak pricing. Critical peak pricing is having a high value. High value in the sense the price will be high. It will be very costly. Very costly. Only very leading industries can be afforded with that price. And peak load pricing, I just discussed them before about it. And the real-time pricing. Real-time pricing in the sense nowadays, see, when you go to some good shopping malls or any textile centers, they will sell. I have seen in one of the leading commercial building, especially in a textile, for next to 2 hours, this shirt is costing only 800 rupees. The actual cost will be 400. Actual cost will be 1200, and they will set only for next to 2 hours, 5 p.m. to 7 p.m. only for 2 hours. This will be of 800 only. 400 rupees reduction they are going to give. This is based on the real-time pricing. Real-time pricing is just in the 1 day before only they will utility body will inform you that. So in the next day, coming day, you are going to have the morning session, this is the tariff, afternoon session, this is the tariff, and the evening and the night session, this will be your tariff, something like that. Based on the demand, the real-time pricing will be adapted for the customers. Yeah, this is the extension of the real-time pricing. The price updating cycle is important aspect of the rate of the structure, and the shorter the updating cycle is, the more efficient. The updating cycle is shorter. I told you 1 day before they are going to inform. If there may be a day, the days will come in 1 hour before only they are going to update the cycle. For next hours between 12 o'clock to 2 o'clock, this will be your tariff. If you consume the power so and so, this will be the tariff. They are going to tell in advance. Either it may be a low price or it may be a high price. Then depends on the demand or power utilization by the all other sectors of the same town. Okay? Things like that. And RTP, real-time pricing, is a dynamic pricing. Dynamic pricing time is, in other words, equivalent word is the real time. That is, in a short interval, they are going to announce the tariff price depending upon the power usage and depending upon the power demand. They are going to fix the price and inform the customers. Those days, those situations are not there presently in India, but if the smart grid technology is incorporated in every town of our India, this is going to come into. That's what I'm telling in one of my explanations. So nowadays we are getting all advertisements, all SMS from the banks to take their roles, or discounted sales from the supermarkets, from the more bazaars and so on. So in the same way, we will be well connected with electricity board if the smart grid technologies are incorporated in every towns. And last one is the RTP, real-time pricing tariff, usually indexes its prices a 2 day ahead or hour ahead of say prices. So in hour or so. So just now I gave some example on the textile line. In the next 2 hours, this is the price of this shirt will be only 800 instead of 1200. In that way, in the next 2 hours, I can give a message to all my customers that in the next 3 hours, this will be your tariff. If you use the power in those hours, this will be your power consumption, and the price is at the lower level or higher value. In that way, they are going. This is about the real-time pricing. Yes, challenging and the implementation of real-time pricing demand response program in this way. The customers on the real-time pricing need to make real-time response to real-time price, and it is too laborious for customers to continuously check real-time prices and then adjust their demand. It is also practically correct. It is a continuously, we cannot monitor the data and or the text or the messages, and we are unable to adjust with that particular demand. And implementation of advanced metering infrastructure or internet-based demand response system at the consumer premises. The implementation is also a challenging task, that is about the advanced metering infrastructure or internet-based DR system. For realize real-time measurement, communication and automated response to RTP, price variation is needed. Yes, in order to implement or in order to have a practical situation of our real-time pricing, a proper communication with an automated response system will be there, and this price variation will be needed. Coming to this, this is the last but one slide. I am going to wind up maybe in a couple of minutes. Please observe here, it looks to be very complex, but it is very, very easy to understand. I have given a title. This is implementation of automated demand response program with the real-time pricing scheme. The very next slide of this will be of a great image where easily you can understand this text. Okay. Now, see here, I have one end. One is the utility side. This is the utility side. The power generation, transmission, distribution is this, and the end consumer over here. In between these two, in between utility side and the consumer end, I have a beautiful home energy management infrastructure. This is a great work. It is there in the home energy management infrastructure. This end user will have these various components as well as the techniques or whatever it is. And in the same way, the utility side will also be having these various tools, maybe control strategies and data storage and so on. What are these? These are having, see here. Now, end consumer and the utility grid are well connected with home energy management. What about this? The each consumer, so this is in the perspective of a smart grid technology I am speaking. In the perspective of smart grid technology. In smart grid technology, every end user should have advanced metering infrastructure. In advanced metering infrastructure, we come across the various smart meters as well as wireless LAN communication system. And also, this end user should have a control system. What are those control systems? That's about the real-time pricing. In the next 2 hours, the tariff of your power consumption will change. Tariff of your price of your electricity may change. Those things. And microcontroller. Microcontroller, why it is required to control the entire system. It may be with the data communication, giving the signal, receiving the signal, and controlling some aspects. And demand response program is also incorporated, and Digital turn-on and turn-off mechanism for home appliances will be incorporated, and all these setups we should have from end user. In the end user, we should have all these setups. In the same way, on the utility grade, we should have all these setup. What are these setup? Slightly different from this group. One is metering database management. It is the database management means a data recording, data analysis, and data computing is to be done. See, here supercomputers we should have for the fast operation and the super speed operation, as well as the data collection. And big data analysis we should have standard deviation, or it may be an estimation for the next month or next year, and the use of a data, previous data, things like that. And Ethernet cloud computing, it is for data sharing, right? We should have an Ethernet with wire communication and data exchange. And electricity pricing. Electricity pricing is a very good deal where the super engineers will be experienced engineers, and the technicians will be working on that, depending upon the generating demand profile. Whatever the generating demand profile, as well as the fixing time based cost. The fixing time based cost depends on the power usage, maybe from the industry, maybe consumer, from customer, from commercial areas, and from transportation or agriculture, and so on. And also forecasting real-time pricing. Forecasting, in a sense, it is predicting the real-time pricing for the existing customers, the various customers, maybe customers from the industry, customers from the transportation region sector, or from the agriculture sector, or so on. So this is, in this way, we should have all advanced control strategies. Sorry, 1 minute. Advanced computers and data analysis equipments and control strategies on the utility side, and also on the end user side. With like us, we should have a smart advanced metering infrastructure and computers and control strategies. So this, if I see this entire thing with this image, please check this. Any idea you are getting? Any idea at your level? Give me 1 minute time. Give me 1 minute time. Okay. Is it visible to you, all of you? Yeah.
Yes, sir, it is visible.
Please check me. In the broad sense, if I share with you my knowledge, so utility is here, the power provider who is well connected through Ethernet with this end. What is this end? I start from here, please. Yeah, here there is a transmission and distribution. Power is supplied. Power is supplied to the smart meters. Through the smart meters, I have connected to the all various loads. It may be a residential load, or it may be your industrial load, or any other loads. And also these are connected with a ZigBee communication network. The ZigBee communication network, which is going to happen in in-house communication. This is an in-house communication, right? So as we are having in this way, these have its own time to operate. During maybe 10 o'clock to 11 o'clock, this washing machine is to be operated. In that way, we are going to program through the consumer interface. From the consumer interface, I have a various loads in my house. I am going to program over here which appliance ought to be operated at which time, duration. I will fix up in that. So that is communicated with your microcontroller and also with the Ethernet switch, right? So we are going to have a communication with this utility to this user consumer through the internet, through the Ethernet, as well as with the ZigBee modules over here. And these appliances will get a message from the microcontroller through this ZigBee network, okay? And accordingly, they will activate the relays. Based on this functionality and the signal or supervising from this microcontroller, these appliances are going to operate for certain duration of time in particular day. That is going to happen. So in this way, it is going to program. The power is accessed over here. Please observe here. Sorry, I have not informed about this. This is the two-way wired communication. This is a data communication, and this is the power source communication. This is solid line indicator. Power line transfer, and this is a dotted line is a wireless communication. I have a wireless communication between the Ethernet and the utility. Again, here I have a wireless communication, whereas this arrow mark indicates a wired communication. This is through the Zigbee to the wire relay to the appliances, we have a wired communication. So in this way, in the home, the entire home energy management you can show in this way, right? I have a proper power flow between the distribution and the network to various all other equipments, and also these equipments are controlled by the programmer or a customer like me who is going to incorporate that program through microcontroller and Zigbee network, through the Zigbee network. And this essentially, this block communication Ethernet switch and Zigbee model will give a connection between this utility and to this consumer in this way. This is a wired communication we have. We need a signal, no, to pass on to this customer. We need a signal, so that's why a Zigbee model is used for the in-house communication. Yeah, this is all about our home energy management. I was thought of speaking to you, but please, my dear delegates and participants, please analyze yourself. Please understand yourself. Whatever we deliver a lecture, it will be of very small information, very limited information. But I definitely, my strong words to the delegates or participants is to read more and more a top journal, top guide, top quality journals, so that you upgrade yourself. In the beginning, you may feel a little difficult or a little bored to read the new articles, but please challenge yourself and please upgrade your career as early as possible, because in every sector there is a high competition. So that if we keep quiet today, the next person, those who are not imagined in our life, he will come forward. Definitely, they will be ahead of us. So in this way, you please think. So if anything is there, you can. Your questions are welcome. Please, is it okay? Our coordinator, Dr. Sindhara.
Thanks, sir. That was a wonderful session, sir. Yeah.
Okay.
Yes, sir. Yes, sir. It is okay, sir. That was a wonderful session, sir. Thanks for presenting a wonderful session, and I hope many research scholars, new research scholars working on this area got benefited because of today's lecture. And there is some question in the chat box, sir. Can I read, sir?
Yeah, please.
Yeah. Subhashish Pandey has one question, sir. Good morning, sir. Is there any policy on the price segregation at demand side consumption pattern in India, like off-peak pricing and peak hour pricing?
Could you repeat once again, please?
Is there any policy on price segregation at demand side consumption pattern in India, like off-peak pricing and peak hour pricing?
Okay. So in this regard, I have a partial answer with respect to this. I have read in one of the articles, especially in the Gujarat or Rajasthan, I really don't remember that state. This is implemented. Whatever the question you asked, right? This is that upon a day-to-time pricing, right? Calculation on. Is it the first? I am looking into that. This one. What is that? Okay, yeah. The question, I have a partially answer. Please don't rely on this complete answer on this. Okay, I have read one of the articles, especially either in the Gujarat or Rajasthan. We have come across a smart grid, a very small smart grid technology. There, it is keeping in the mind of some industry, some particular industry, maybe chemical industry and textile industry. They have initiated this policy. Yes, I agree with that. Who is that, please? Could you tell his name from Andhra Pradesh?
Subhashish Pandey has this question, sir. And Manohar Talari from Andhra Pradesh, he said that in Andhra they have already implemented the day-ahead pricing scheme.
Okay, very good, very happy to know about it. So shortly we are going to get across all the leading towns and leading cities in the India also. Good, Manohar Talari. Good. Okay. Yeah. Any others, please?
Participants, if you want to ask, you can.
Yeah, participants, all other participants are welcome for this.
Participants, if you have any other queries, you can ask our today resource person for your queries on this demand side management.
Yeah, one question I got from Manohar Tilari: is there any energy auditors there in the session? Please, anybody can come forward. Anybody is energy auditors are there, please? Voluntarily, you can inform, you can communicate with Manohar Talari. Uh, so it is a really good. The energy auditor. So we do an uh, energy auditing system in our university, but we don't have any certified energy auditor. As of now, myself, I am not a certified energy auditor. With respect to this BEE, Bureau of Energy, I hope Electrical Energy, Bureau of Electrical Energy. Please note down Mr. Manohar Talari. BEE is a central government organization body. They are going to conduct the energy audit certification course and program. If you are interested, you can become a good leader in India. In the Indian level, you can, if you take up that examination and qualify, no, definitely it will be a great achievement in your life. So I think you may be knowing about it. I think you may be knowing about it. The BEE, Bureau of Electrical Energy. So it is a central body, central government body. You can have its program that is on examination as well as the certification program can come up. Yeah, please.
Thank you, sir. And thanks for the appreciation given by our today participants. And for today's session feedback link, I have shared in the chat box. And thanks for joining for the first day of the forenoon session. Thank you for our today resource person, our HOD sir. Thank you so much, sir. On behalf of New Horizon College and the Department of EE, I was very happy to conduct this session, and I welcome our participants to join in the afternoon session also. Today afternoon session is given by Vijay Kumar sir from IIT Kanchipuram. Please join the session. That is also going to be a really interesting session. Once again, I welcome for our participants. Thank you so much.
Thank you, Ananda. Thank you.
Thank you, sir. And the recorded section will be uploaded in the YouTube, and it will be later shared with our participants.
Okay. Okay. Thank you.
Thank you, sir. Sir, you can stop sharing the screen, sir. Nice.
Thanks. Tell me correctly.
Yeah, very good. Very nice, and the content was really nice. Like I sing my repeating my viva. So we can stop sharing. So please share it.
Yeah, I think stop now. Okay.
Stop sharing. Or you can leave the meeting.
Okay. Went well, no problem.
Super. It was nice.